Okay, so today we're going to solve equations that contain fractions. If you take a look at this whole page, all fractions in those equations. But that's okay. We can still solve for the value of x in each of these. And the first type we're going to solve is called the cross-multiplying type. Cross-multiplying is a process you use to solve for the missing piece in a proportion. Remember, a proportion is just two fractions set equal to each other, like this. And if one of those four pieces is missing, you can cross-multiply to solve for it. Well, if you take a look at exercise 1A, on the left side we have ourselves a fraction. I mean, the top of it, the numerator is kind of a mess, but it is a numerator over a denominator, so it is a fraction. And on the right side of the equation we have a 9, but we know that we can put 9 over 1, and it's equivalent to 9. Now we have a fraction set equal to a fraction. So this is actually a proportion. We can cross-multiply to solve it. We go diagonally this way. 1 times 6 parenthesis x plus 2 just gives us 6 parenthesis x plus 2. Multiplying by 1 doesn't change anything. The equals goes in the middle. And now we're going to multiply this way. 4 times 9 gives you 36. Look, our fractions are gone. And we know how to solve this. To get rid of the parentheses, we distribute. 6 times x gives me 6x. 6 times 2 gives me 12 equals 36. To get that x by itself, I'm going to subtract 12 from both sides. And with 6x equals 36 minus 12 is 24. Dividing by 6 on both sides, I end up with x equals 4. 24 divided by 6 is 4. Now, as we talked about previously in set notation, here's what that would look like. X such that x is equal to 4. In letter B, same situation. We have a fraction on the left side. This time the top and the bottom is an expression, but it's still a fraction. And on the right side we have a 2, which we can put over 1 to turn into a fraction. We now have a proportion. We can cross-multiply to solve this. Now, when I do 1 times 3x plus 5, technically I could write it this way. 1 times 3x plus 5. The equals goes in the middle. And then when I do 2 times 2x minus 1, it's going to look like this. Now, typically when you multiply 1 times 3x plus 5, you would just write 3x plus 5 because distributing a 1 through the parentheses doesn't change anything. The reason I wrote it this way for you today is because I just want you to see the difference between when you're multiplying by 1 and when you're multiplying by a number greater than 1, like 2. It really does have to get distributed through the parentheses. On this side, we're left with 3x plus 5. On this side, you're going to get 2 times 2x, which is 4x, and 2 times negative 1, which is negative 2. This one's a little different than letter A because now we have a variable on both sides. We have to get the variable to one side, so I'm going to subtract 3x from both sides. I certainly could have subtracted 4x from both sides as well, but I like to keep my x variable positive. These cancel. I'm left with 5 is equal to 1x minus 2. 1x comes from taking 4x and subtracting 3x from it. Adding 2 to both sides, you see that x is equal to 7. On this next one, you have a fraction on the left side and this expression on the right side. Well, still, even though that's an expression, you can put the whole thing over 1. Make it look like a fraction, and now we can cross-multiply to solve it. 2x times 1 gives me 2x. The equals goes in the middle. And then we're going to do 3 times 14 minus 4x. When we distribute to get rid of the parentheses, 3 times 14 is 42. 3 times negative 4x is negative 12x. Again, we have the variable on both sides. Your goal is to get the variable on one side and a number on the other side. Well, since we already have the number on the right side, I'm going to get rid of the 12x. Add 12x to both sides. 2x plus 12x gives me 14x. These cancel. I'm left with 14x equals 42. Dividing both sides by 14, 42 divided by 14 is 3. X is equal to 3. Now when we take a look at these next examples, you're going to see a little difference here. Let's say that the x over 5 and the plus sign were not there, that this piece here were gone. If you covered that up with your finger, you would just see that it was x over 2 equals 14. You could put the 14 over 1 and cross multiply to solve it. You actually cannot cross multiply to solve this one yet, because it's not a fraction set equal to a fraction, it's a sum of two fractions set equal to a fraction. So in order to cross multiply, we have to first find the sum of x over 5 and x over 2. Now back in Ms. Dromgold's class, when you learned how to add fractions, you learned that you need a common denominator. Our denominators are 5 and 2. So I'm going to use 10 as my common denominator, because 5 is a factor of 10 and 2 is a factor of 10. Well, if we change the denominator to 10, the numerator has to change as well for the fraction to remain equivalent. Well, 5 times 2 gave me 10, so I just need to multiply the numerator by 2 as well, giving me 2x. And 2 times 5 gives me 10, so I just have to multiply the numerator by 5 as well, and it gives me 5x. And now I can add these fractions together. 2x over 10 plus 5x over 10 gives me 7x's over 10. I can set that equal to 14 over 1. And now that we've added those fractions, we have a fraction set equal to a fraction. We can cross multiply to solve it. 7x times 1 gives me 7x. The equals goes in the middle. And 10 times 14 gives me 140. I end up with 7x equals 140. To finish getting x by itself, I divide both sides by 7, and 140 divided by 7 is 20. You get x equals 20. In set notation, again, x such that x equals 20. You will never get points off if you don't write your answer in set notation. I just want you to be familiar with it in case on a multiple choice question the state decides to write their answers in set notation. Or in case the directions ever simply say write your answer in set notation. It could happen. On this next one again, we've got to actually add these fractions together before we can cross multiply. Hold on one second, I got to let Murphy in. Alright, so again, this next one we have to add these fractions first. Our denominators are 2 and 6. I'm going to use 6 as my common denominator, because 2 goes into 6 and so does 6. 2 goes into 6 3 times. Multiplying the numerator by 3, I get 3x here. We didn't change the denominator here, so the numerator doesn't change either. 3x over 6 plus 1x over 6 gives me 4x over 6. I can put the 2 over 1. I now have a fraction set equal to a fraction, so I can cross multiply. 4x times 1 is 4x. The equals goes in the middle. 6 times 2 is 12. Dividing both sides by 4. 12 divided by 4, you see x equals 3. Now this next one, again, it looks like you can use 6 as your common denominator, because 3 goes into 6, and obviously so does 6. 3 goes into 6 2 times. Multiplying the numerator by 2, 2 times 2x gives me 4x. 2x over 3 is equivalent to 4x over 6. This one doesn't change. 4x over 6 plus 1x over 6 is 5x over 6. I can put the 5 over 1, and now I can cross multiply. Oh, I wish I could videotape my dog right now. For some reason, he doesn't realize that that tail is attached. Cross multiplying 5x times 1 gives us 5x. The equals goes in the middle. 6 times 5 gives you 30. Dividing both sides by 5, you see that x is equal to 6 because 30 divided by 5 is 6. So that's when you have a sum set equal to a number. Before you can cross multiply, you have to add the fractions together. It could also happen with a difference. You would have to subtract the fractions, but you'd use the same process. Excuse me. You might be wondering why I rewrote the same 3 equations again. I did that because I'm going to teach you a second method where when you have a sum or a difference set equal to a number. And this is what the math teachers at Odyssey call the I hate fractions method. If you like this method better than the common denominator method, then go ahead and use it. Doesn't matter to me which one you use as long as you know what you're doing and you get the right answer. Here's how you use the I hate fractions method. You basically take a look at the two denominators you want to get rid of. In this first one, we want to get rid of a 5 and a 2. So what you do is you take the denominators you're trying to get rid of and you multiply each term in the equation by that 5 and that 2. Even this guy out here. You got to do every single term in the equation because otherwise you won't keep the equation balanced or equivalent to the original equation. Now look what happens when we do that. In this first term, we have a 5 in the top and a 5 in the bottom. Guess what? Those cancel out. You're left with just 2 times x, which is 2x. In this second term, this 2 in the bottom cancels with this 2 in the top. You're left with 5 times x, or just plus 5x. On this side, you have nothing to cancel with in the bottom because this 14 is just over 1. So you just multiply 14 times 5 times 2. Well, 5 times 2 is 10. 10 times 14 is 140. See? You hated fractions, so you got rid of them. Now we can combine like terms. We end up with 7x equals 140 because 2x plus 5x is 7x. Dividing by 7 on both sides, 140 divided by 7 is 20. And 20 is the same thing we got up here. We got x equals 20. Just used a different method of solving. In this next one, the fractions we want to get rid of, or excuse me, the denominators we want to get rid of are 2 and 6. So I'm going to multiply this term by 2 and by 6. This term by 2 and by 6. And even this term over here by 2 and by 6. Now this 2 in the bottom cancels with this 2 in the top. I'm left with 6 times x, which is just 6x. This 6 in the bottom cancels with this 6 in the top. I'm left with 2 times x, or just 2x. And on this side I have 2 times 2, which is 4, times 6, which is 24. Combining like terms, 6x plus 2x is 8x. I end up with 8x equals 24. Dividing both sides by 8, you get x equals 3. On this last one, I apologize there's not a lot of room, but the denominators we want to get rid of are 3 and 6. So I'm going to multiply this term by 3 and by 6. I'm going to multiply this middle term by 3 and by 6. And even the 5 gets multiplied by 3 and by 6. 3 in the bottom cancels with the 3 in the top. I'm left with 6 times 2x, which is 12x. 6 in the bottom cancels with the 6 in the top. I'm left with 3 times x, which is just 3x. 5 times 3 is 15. 15 times 6 is 90. I'm left with 12x plus 3x equals 90. Combining my like terms, 12x plus 3x is 15x. I get 15x equals 90. Dividing both sides by 15, I get x equals 6. 90 divided by 15 is 6. Same thing we got up top, we just used the I hate fractions method instead of the common denominator method. So when you come into class next time, be ready to work with these equations involving fractions and have your notes ready to show me, and have a wonderful night.